the observer, the physics of the observer, so important?
We've learned that what answer you actually get out of your mathematical theories of physics depends on how you define an observer. So, for example, if you just start with pure quantum mechanics, just the math, you just have this thing called a wave function doing its thing, and in order to calculate what we actually observe, that things happen with certain probabilities. If you take instead the problem of making sense of modern cosmology, where you have this huge, maybe infinite, diverse space that's been created by an inflationary expansion in our early universe, and you want to predict how much dark energy you should observe, then it turns out you instead get the right answer if you assume a little bit more about your observer, if you assume that it needs to have a galaxy to live in. There's another thorny problem in quantum mechanics where I think you have to assume even more and say that an observer is something which is also conscious in order to get the right answer. So that's why it's so important that we really drill down and understand how we define an observer, because it affects the predictions.
So you've made two huge leaps. The first leap is that you need something to observe. The second one is that that observer might have to be conscious.
Yeah, so that's another thing. Should we be surprised that we observe our universe to be 13.8 billion years old? Would it be much more likely that we observe it to be 100 years old? Probably not, because it was too hot then to have any galaxies or any stable structures that could process information and think. If we live in a very diverse space and time where, for example, the amount of dark energy changes from place to place, we should expect to see the things that typical observers see. But what's typical depends on what an observer is. And even though people here don't agree about how we should define an observer, I think they generally agree that the predictions our theories make depend on what we mean by an observer.
Quantum mechanics is counterintuitive. What happens at the subatomic level makes no sense at our human level. I know enough of the math and the exquisitely precise experiments to be sure that quantum mechanics is real. But I'm baffled by the huge gap in scale between observers, sentient creatures like us, and what they observe in the subatomic realm. I put the problem to FQXI's co-scientific director, cosmologist Anthony Aguirre.
You have to remember how physics started out. You know, it didn't always start out with subatomic particles. There were planets in the beginning. So, you know, when Newton first formulated his laws and gravity, the universal law of gravitation, those were all astronomical objects, and you didn't have to think about observers. This was objective reality. But a really interesting thing happened, of course, in the beginning of the 20th century when all of this basically fell apart with the advent of quantum mechanics. And, you know, physicists resisted it. They saw that as they tried to formulate the laws of the very small, they found that, you know, whatever you do, your act as an observer just inevitably affects it. And this seemed at first like, well, that's just an annoying thing. But the more people kind of studied it, they found that this was not just a sort of
an artifact
irritating
of
artifact.
Yeah,
it was a part of nature that not only could you inconveniently affect things, you inevitably affected things. And so starting then with sort of the creation of quantum mechanics, the observers become sort of more and more wrapped up in physics. You can't describe quantum mechanics without talking about the observer.
How do you distinguish between the observer being a sentient being and a measurement device?
I'm looking at a tree, I'm the observer that's looking at the tree. But when we're talking about a subatomic particle, we take that tiny thing and sort of amplify the information in it up to a scale that is useful and sort of on a macroscopic level where I can look at the readout on the machine. But where does the observation actually take place? I'm reading, you know, a little dial out. I'm observing the quantum system.
So now are you part of it too?
Am I part of it too? Am I part of the quantum system? Or does the buck stop with me? You know, where I'm ultimately the observer has to be something like me that thinks, that imagines, and so on. And I think we don't really know what is enough to make the observation happen.
Is an observer needed to make quantum mechanics work? Must the observer be a conscious entity? Why are observers relevant in cosmology? Each of the questions touches fundamental issues. I start with the quantum. Here's the core conundrum. How does our normal definitive world emerge from the quantum probabilistic world? And what's the role of observers? I asked physicist, cosmologist, author Sean Carroll.
Basically, every college physics department that teaches quantum mechanics tells the students the same thing, and almost no physicist really believes it. And the thing we tell them is that there are quantum mechanical systems, like a nucleus that might decay or an atom that might radiate. And what quantum mechanics is able to tell you is when you, as an observer, make an observation of the system, what is the probability that you see different experimental outcomes? And so the very formulation of the rules of quantum mechanics, as we teach in the textbooks, involves the existence of an observer. But deep in the heart of almost every physicist is the conviction that the existence of a person, which is what it sounds like when you say the word observer, that shouldn't be part of a real physical theory. So there's sort of a minority of physicists who've taken up the radical point of view that no, you can't even define quantum mechanics without really taking observers seriously as part of the fundamental ingredients of the theory. The rest of us are trying to say, well, what we really meant all along by observers is something else, some part of the system that interacts with some other part of the system in another way. So I, for one, am happy to count video cameras, rocks, atoms and molecules in the air as quantum mechanical observers for all intents and purposes.
So an observer can be any kind of interaction? No necessity for a living, sentient kind of observer? I confer with quantum information expert and FQXI regular, Seth Lloyd.
Every physical system ranging from the size of elementary particles like electrons up to the human beings, society itself, or stars and planets, or even the whole universe can be considered an observer, because every physical system is interacting with its surroundings and getting information about it. So if getting information about the rest of the universe is observing it, then even an electron is an observer. But 100 years ago, when quantum mechanics came to the fore, then an observer plays a more central role, because you can't get information about a physical system, quantum mechanical system, without disturbing it.
And that type of disturbing is measurement classically, but does that have to have a sentient observation, as some have claimed, which sounds incredible?
The problem in quantum mechanics is that you have this quantum weirdness called wave-particle duality, where electron over here corresponds to a wave over here, electron over there corresponds to a wave over there, but electron here and there at the same time corresponds to a wave in both places at once. So then the question is, why do we see electron in one place rather than another? And the notion of an observer is invoked to say, oh, electron will show up either here or there if an observer comes in to see that it's here or see that it's there.
And the observer in that case is a measurement, not necessarily a sentient creature.
Right, but if the measurement apparatus is itself a quantum mechanical system, then
Which everything is.
Then actually the quantum description of what's going on is not either measurement apparatus finding it here or measurement apparatus finding it there, but measurement apparatus finding it here and there simultaneously, and that's kind of a bummer. And so Wigner and others actually said, well, what could it possibly be that makes things finally be here or there rather than here and there at the same time? And he said consciousness. For better or worse.
To Seth, like to Sean, an observer in quantum mechanics need not be a conscious being, though it can be. That sounds sensible, while requiring a conscious observer sounds ludicrous. I know a philosopher of mine who argues that consciousness goes beyond physics. Dave Chalmers is here in Banff.
It's hard to begin to talk about observers without talking about consciousness. Maybe you can find a notion of observation so that anything that affects one other thing, then the other thing is making an observation. I get the sense that when these physicists are talking about observers, they're talking about something a lot more robust than that. They're talking about something like us, when we perceive the world and experience what's going on, and that's a kind of act of consciousness.
So what is the nature of consciousness that could affect quantum physics before there were sentient creatures?
There's a number of different possible roles for observers in physics. One role is just epistemological. For example, the very fact that we are here as conscious, observing beings tells us something about the universe, which puts some constraints on the physics of the worlds. And that's a less controversial role for observers.
Some people would have consciousness playing a very fundamental role that it wouldn't exist without the conscious process.
So that's the more radical thesis. In the traditional formulations of quantum mechanics, it says there's this wave function and it evolves, and every now and then there's a measurement or there's an observation. And when that happens, something changes. The wave function collapses into a new state, and suddenly it looks like observation, consciousness, is playing a role in the dynamics. And for a lot of people, that's hard to stomach, and they've tried to find ways out. You mentioned a problem. Wasn't the wave function evolving for a long time before consciousness ever came along? Well, I suppose one view is that, yeah, well, for all those, billions of years or whatever, the wave function was just evolving without collapsing, and suddenly in one branch, the first conscious observer came along and then collapsed the wave function into a definite state for the very first time. Now that's a radical view, yeah. But on this view, this is a view where consciousness actually plays a role in creating determinate reality.
I hear that physicist Paul Davies makes consciousness fundamental. Can he explain the eons of time before conscious beings appeared?
There's a simple answer and a more subtle answer to that. The simple answer is, well, something can be fundamental but not always be there. So particular fundamental particles, say the electron, probably didn't exist during the first split second of the universe. So that's the sort of simple explanation. But there's a more subtle one, and that is in quantum physics, the relationship between events across time is rather different from what it is in sort of daily life and common sense. And that's because the acts of observation today can not only affect what's going to happen in the future, but in some sense constrains what happens in the past. And this was spotted by John Wheeler, the great theoretical physicist who devised a thought experiment called the delayed choice experiment, but the upshot being that the observer could choose whether to make one type of measurement or another, and which choice the experimenter made would affect the nature of reality at the other end in the past. And so it looks like retrocausation, and that is true in a sense, but it's not that we can change the past by making choices of what to observe now. We're not changing the past, but we're constraining the nature of past that was. In quantum physics, you have fuzziness and incomplete information about the world, and so there are many, many possible pathways that connect the Big Bang with our present state. And when we do an observation, we reduce the number of possible pathways that could exist. And so in that sense, what we do today affects the nature of reality as it was in the past. It doesn't change the past. So in that somewhat abstract sense, observers today are still relevant to the quantum physics of the Big Bang. The emergence of conscious beings at some stage in the universe is fundamental to the actual workings of the universe. It's not an incidental.
To Paul, as to Dave, consciousness is fundamental. You can't have an observer without having consciousness, and this includes the subatomic level of quantum physics.